In Lesson 2, we're going to talk about rationalizing numerators and denominators. Normally in the past, you guys have seen rationalizing before. This again is the, as you can see here, process of removing the radical. Now normally what we've done is we've removed the radical that has been in our denominator because we've said, okay, anytime you have a radical in your denominator, it's not in lowest terms. What we're also going to look at is reducing that or getting rid of our radical in our numerator as well. And the good thing is it works the exact same way. So first let's do a little bit of a recall. Recall that the conjugate, so conjugate is that little magic thing that helps us get rid of that radical. The conjugate of any expression of the form x plus root a is x minus root a. So you'll notice all we're doing is we're changing the signs, and vice versa. Rationalizing also often involves multiplying the numerator and denominator by the conjugate of the expression that's being rationalized. So for 11, it's saying rationalize the denominator of the expression. So denominator, we're looking at our base here. And notice that I've got root x minus 2. So according to this up here, all we're doing is changing the sign. So this is going to become root x plus 2. But of course, what I do to the bottom, I have to do to the top. And again, this whole idea is to allow us to get rid of that radical in our denominator. Now, one thing that you might want to keep in mind is that there is a shortcut when we use our conjugate. Now notice that I've got a binomial times a binomial in my denominator. The good thing with a conjugate is that you only need to multiply your first term and your last term. You don't need to do the whole FOIL process. So this is going to become 2x times root x plus 2 divided by, and when I take that, root x times root x, just x, negative 2 times positive 2 is going to give us negative 4. Then what we could also do is simplify. So again, you'll notice that we don't have a radical in our denominator more, which is really good. Now what we can do is actually multiply through. So rather than do 2x times root x, remember that root x is the same as x to the power of a half. That's like that flower power thing that you learned way back in Math 10C. This is like x to the power of 1, and this is the square root. Okay, so this would be the same as 2x times x to the power of a half plus 2 over x minus 4. And if I multiply in, remember this is x to the power of 1, so I'm just adding my exponents. So that would be 2x to the power of 3 over 2 plus 4x all over x minus 4. Okay, so that would be our answer since we've got rid of that radical in our denominator. In the next little bit of practice, it's saying rationalize the denominator in each of the following expressions and then simplify. So in these, you will notice that in our denominator is where I have the radical. And remember, you don't need to overthink this. Your conjugate is just the opposite of what you see. So x plus 2 root x. But again, have to do that same thing to the top. Now the top, I'm just multiplying it by 1, so that's pretty straightforward. Just going to be x plus 2 root x on the top over, and then the bottom here, remember, I only need to multiply the first and the last term because the middle terms are always going to cancel out. So I've got x squared, and then minus and a positive is going to become a negative. 2 root x times 2 root x is going to become 4x. I could factor the denominator if I really wanted to. I could also say x plus 2 root x over x times x minus 4. And again, just making sure that you guys know different forms of the same thing. That'll help you choose the right answer on your assignment. B, this, we have 2 radicals. Does not make a difference. I'm still keeping the same thing, and my conjugate is just going to be the opposite side. Or I'm sorry, sign. Now this one's a little bit more of a pain because it looks basically like we need to be multiplying out our top. So basically you would think like we would have to FOIL that all out, blah, blah, blah. My hint to you is don't expand unless you have to. So let's see what this is going to look like. I'm going to have x minus 5 times root x minus root 5, which again we would have to expand. unless we notice something about our denominator. This times this is just going to be x. This times this is going to be 5, and a positive times a negative is going to give us a negative. So now, hopefully you can see, boom, boom, we can cancel those out. So that definitely saved us from expanding. I'm going to say that a lot throughout this course. Don't expand unless you absolutely have to, because sometimes it makes things a lot harder. And that would be our final answer there. If we just do a couple of more, and then I'm going to end this lesson and move on to something different. The only difference between these questions and the other ones that we've done is this is saying rationalize the numerator. And you'll notice that I have my radicals in my numerator. The good thing is, guys, nothing changes except we're looking at my numerator instead of my denominator. So the conjugate is just going to be 2x minus 5 plus root 7. But again, what I do to the top, I must do to the bottom. Okay. So if I multiply this all out, okay, basically I've got the top now. I'm following those rules. This is just going to be 2x minus 5. And then this guy times this guy, root 7 times root 7 is just going to be 7 with a negative in front of it. And then the bottom, like I said, don't expand unless you have to. We're going to take that x minus 6, and I've got root 2x minus 6 plus root 7. So let's keep simplifying here. I've got my 2x minus 5 minus 7, which is going to give us 2x minus 12 over x minus 6, 2x minus 6 plus root 7. Now, if you notice on the top, we can definitely factor out a 2. And when we do that, we're going to be left with this, which is really good because just like that last question, you can see that we can simplify. Okay, I've got an x minus 6 and an x minus 6. So those can be gone, and we're just going to be left with a 2 over root 2x minus 6 plus root 7. So again, please follow my advice and don't expand unless you have to. Lots of kids really like to expand, and then it just gets way crazier on them. All right, so this guy here for B, you might look at it and say, well, wait a minute, there is no numerator. Like, this is just a nice little expression here. Well, we can always make it a numerator by putting it over 1. So it's saying rationalize our numerator. Okay, well, if I put that over 1, now I need to do the same thing and get rid of that radical in the top by multiplying by the conjugate. So it's going to be plus 1 and root x plus x minus 11 plus 1. Okay. Now when we go ahead and multiply through this guy times this guy, nice and easy. I'll do this in a different color so you guys can not get things mixed up. It's just going to be x squared plus x minus 11. And then this guy times this guy is just going to be minus 1 over that denominator. X squared plus x minus 11 plus 1. And then we can go ahead and simplify. So I've got these two like terms. So x squared plus x minus 12 over root x squared plus x minus 11 plus 1. And that's it. There's nothing that we can combine or simplify or cancel out, so we can just circle that as our final answer.